Hello students, welcome to my YouTube channel. I am Shlok Kulkarni and in this video lecture I am going to start answering questions from ILS chapter in Keith Williams Radio Navigation book. I have solved many other chapters from this Keith Williams Radio Navigation book like VOR, ADF, DME, Radar, Airborne Weather Radar, etc. So do visit the playlist that I have made specially for Keith Williams Radio Navigation, and in that playlist you will find all the relevant lecture videos. So now let's start with question number 1 of ILS chapter from this book, which is question number 1. The amplitude modulation and the color. So amplitude modulation and color of outer marker is what? So your ILS system, your ILS system is made up of four components. The localizer for horizontal guidance, your glide slope, your vertical guidance, and third, your marker beacons, correct, which tell you the information of your distance, which tell you about your distance from the runway. And the fourth is PAPI lights, an approach light system. Okay. Now, out of this marker beacons, now there are three marker beacons: the outer marker, the inner marker, the middle marker, and the inner marker. Now, all these marker beacons, outer, middle, and inner, transmit on a frequency of VHF 75 megahertz. This is the main carrier frequency. And this frequency, this main carrier frequency, is further amplitude modulated by different frequencies. So for outer marker, it is amplitude modulated at a frequency of 400 hertz. Middle marker, it is amplitude modulated by a frequency of 1300 hertz. Inner marker, it is frequency modulated at 3000 hertz. Okay, so these are the amplitude modulation frequencies, and the main carrier frequency is VHF 75 megahertz. Next, remember the colors: outer marker blue, amber, white, BAW. Okay, blue, amber, white. Next, remember the identification. Now, outer marker is identified by continuous dashes. Continuous dashes. The inner marker is identified by continuous dots. The middle marker is identified by alternate dots and dashes. Okay. So outer marker, two dashes every second. Middle marker, alternate dots and dashes, three per second. So two, three, and then dot, six dots per second. So two threes are six. Remember like that. Two, three, six. Two threes are six. Next, the pitch. So here you will hear this identification at a low pitch, at a medium pitch, and at the high pitch. Okay, this is how you remember. So you have to remember the positions. Now next position, distances. Outer marker is 6.5 to 11.1 kilometers. It's not nautical mile, it's kilometers. So remember that unit. Convert that into nautical mile also. Middle marker is 1050 plus minus 150 meter. Okay, not kilometer, it's meter. And then inner marker is very close to the runway, 75 to 450 meters only. Okay, so amplitude modulation of outer marker. So outer marker is amplitude modulated at 400 hertz, at 400 hertz, and the color as you can see is blue. So the correct answer here is 400 hertz and blue color. So option Charlie. Next. A Cat 1 ILS ground installation provides accurate guidance from coverage limit down to what? Okay, so there are different categories of ILS. Okay, Cat 1, Cat 2, Cat 3, Cat 3A, Cat 3B, Cat 3C. Okay, so there are three different categories of ILS. Now, depending on the outside meteorological conditions like yes, cloud ceiling, visibility, you will determine what category applies to you, whether the conditions outside are Cat 1, Cat 2, Cat 3, whatever. Now, a Cat 1 ILS system, a system which is qualified for Cat 1, it will provide provide vertical guidance. It will provide vertical guidance up to 200 feet above the surface, up to 200 feet. Okay. Beyond 200 feet, it is not reliable. That system cannot provide accurate vertical guidance. That is less than 200 feet. So maximum limit up to 200 feet, it can provide accurate guidance. Minima. System minima is 200 feet. Okay, visibility 60 meters or 200 feet. RVR equipment. RVR requirement not less than 550 meters or ground visibility not less than 800 meters. Okay, so this is your cat 1. So you have to remember decision height and remember this minima, the minimum visibility. So next, look at this diagram. So cat 1. So cat 1 starts from here. Okay, the visibility requirement for cat 1 is much more than the visibility requirement for cat 2. For cat 2 is just 100. For cat 3 there is no visibility requirement. So here they have not shown any visibility requirement for cat 3. So for cat 1 you must be able to see 200 feet from this, 200 feet away. Okay, so this is your visibility requirement for cat 1. Decision height 200 feet. So you will get vertical guidance only up to 200 feet. For Cat 2, you will get guidance up to 100 feet. So you will come much closer to the ground if you're following or you're qualified for exercising Cat 2 uh, Cat 2 approach. Okay, or executing Cat 2 approach. So Cat 1 ground installation provides accurate guidance from coverage limit down to 200 feet above the runway threshold, 50 feet above the ILS reference point, that is your threshold, runway surface 200 feet above the inner marker. So 200 feet above the ground level, that is above threshold. Okay, so 200 feet above the runway threshold. Next, the reason why pre-takeoff holding areas are sometimes further away, much more away from the active runway when Cat 2 and Cat 3 operations are ongoing during good weather operations or bad weather operations is what? So look at this. So now this is a part of regulations. If you have done aerodrome chapters, you will study about all the aerodrome markings and paintings, all that. So now this, there are two holding points that you can see here. This one, and this is the second one. Now over here, this one is your runway holding position marking. This dotted lines will be towards the runway. This solid lines will be away from the runway. So that means you are going straight ahead towards the runway. Runway is somewhere here. Okay. So dotted lines will point towards the runway. Always remember. Next, there is this second holding point. So there is one holding point in the beginning and there is another holding point beyond it. This holding point is runway holding position marking again. So there are two types of runway holding position markings. Pattern A is this, two broken lines, two solid lines. Pattern B, it's like a ladder. Okay, now why is this installed? Now this pattern B is called ILS holding point. That means in normal conditions when ILS Cat 1 operations are being executed or followed, you will park your aircraft or you will hold your aircraft short of the runway at this position. Hold short of this holding pattern. But when ILS Cat 2 Cat 3 operations are ongoing, you will hold your aircraft short of this ILS holding point. Okay, so you will park your aircraft here when ILS Cat 2 Cat 3 operations are going on. Otherwise, you will park your aircraft over here, wait for your takeoff clearance or liner clearance. So you can see this is the runway. Okay, here is the runway. Here is this holding point, same as that. So hold marking for land and hold short operations or just holding point if you want to enter the runway. Similarly, here there is a holding point just like this if you want to enter the runway. There is another holding point here which is like this. That is ILS holding point. So when Cat 2 Cat 3 operations are being carried out, you will park your aircraft or you will stop your aircraft short of this holding point somewhere here. Not short of this, but here. Much farther away or further away from the active runway. Okay, so this is the thing. Next, over here, read this. Indicate. So holding position marking for ILS, the ladder shape. It indicates the boundary of the ILS critical area. Don't cross unless cleared. When exiting the area, a yellow ILS critical area boundary sign will be adjacent this marking. All parts of your aircraft must cross this marking to be clear of the ILS critical area. Okay. So over here, when ILS approaches are in progress, you may be asked by controller to hold short of the ILS holding line, like here. Over here, hold lines consist of two solid lines and two dotted lines or dashed lines. Your aircraft is clear of the runway when it is on the side of the solid lines. Your aircraft, the whole structure must cross this dotted solid, two yellow solid lines. Only and only then you will be regarded as being clear of the runway. When you exit the runway after landing, be sure to cross the holding line before stopping to ensure that you are clear of the runway. Okay, the entire tail structure, entire aircraft along with the tail structure, tail part of it must be cleared of that runway. And how to determine that? You must be beyond the yellow solid lines, these two yellow solid lines. Okay, so over here, what is the reason we have this ILS holding point? Uh, Heavy precipitation may disturb guidance signals to increase distance from the runway during offset approach operations. Aircraft maneuvering near the active runway may disturb guidance ILS signals to increase aircraft separation in very reduced visibility conditions. So option C is the right answer. Okay, we have ILS holding points so as to position all aircraft away from the active runway so that they may not interfere with the ILS operations or ILS guidance signals. Aircraft tracking to intercept ILS localizer inbound on the approach side outside the ILS coverage angle will suffer from what drawback? So, now this is your runway. Now this will be your ILS localizer signal. Now your ILS localizer antenna will be installed on the opposite side of the runway. You're you're approaching the runway from this side. The ILS localizer antenna will be on the opposite end of the runway. Now that ILS localizer antenna will transmit two amplitude modulation signals. Okay, the ILS localizer operates in the VHF band anywhere between frequencies starting from 10.81 odd decimal towards 111.95 odd. So between 108 and 112 megahertz, only the odd decimals, frequencies with odd decimals are allotted to ILS localizer. Now this main VHF carrier wave is further amplitude modulated 90 hertz the left signal, 150 hertz the right hand signal. Remember that. Now this ILS localizer coverage area, the limits also you must remember. Okay, so 18 nautical miles, 10 degree either side of the center line. When you go closer to the runway, 10 nautical miles when you are 10 miles away, okay, you get a coverage of 35 degree either side of the center line. When you go far away, the coverage area decreases 10 degree on either side. When you go much closer to the runway, you will get 35 degrees of coverage on either side of the center line. Okay, so this coverage area you must remember. Now the question has asked us, when any aircraft approaches this ILS system or tries to connect with this ILS system, when it is outside this coverage area, somewhere here, but outside this limits of the coverage area, what will happen to it? Will it be able to successfully receive the ILS guidance signal? Will it be able to hear the identification? Will the signals that it gets or receives are going to be reliable or not? So the correct answer here will be this. It will receive the signals, but they may not be reliable. So option Bravo is the right answer. May receive false course indications. Okay. So any aircraft outside the published coverage sector may receive the signals or may not receive. Okay. That's why option Bravo is the safest option. It may receive false course indications. Option A will not normally receive signals, will receive signals without identification, can expect signals to give correct indications. So it may receive signals, it may not receive it, it will definitely receive the identification. Okay, next. So remember this localizer coverage sector. Okay, uh, azimuth. So normal limits of localizer coverage, the same area applies to a back course when provided. So when you are away from the localizer antenna at a distance of 18 miles, you get 10 degree either side of the center line. 10 miles away, 35 degrees either side of the center line. Okay, next. The middle marker of an ILS is identified audibly. Audibly means hearing, visually means looking at, by a series of what? So, same question, similar question. So now here they are talking about middle marker. Read the question carefully. So, middle marker color is amber. Okay. Identification alternate dots and dashes 3 per second. Amplitude modulated 1300 hertz. So, so audibly you will hear alternate dots and dashes, and visual color is orange or amber. So option A, alternate dots and dashes and an amber light flashing. Yes, so option A is the right answer. Two dashes per second, blue light flashing. That is a feature of an outer marker. Dots and a white light flashing. So six dots, white light flashing, inner marker, dashes, amber light irrelevant. So option A. The outer marker of an ILS transmits on a frequency of what? It transmits on a frequency. So transmission frequency have been asked. So like I said, all outer markers, all marker beacons, outer, middle, inner, transmit in the VHF band of 75 megahertz. And these frequencies are further amplitude modulated with respect to every marker beacon. Outer marker 400 hertz, middle marker 1300, inner marker 3000 hertz, right? So outer marker transmits on a frequency of 75 megahertz and it's modulated by continuous dashes 2 per second. So correct answer is option delta. 75 megahertz and a Morse code of 2 dashes per second. What approximate rate of descent in order to maintain a 3-degree glide path at a speed of 120 knots is required? So do watch my video lectures on 1 in 60 rule that I have done from Oxford GenNav book, RK Bali book, and also descent questions, which has all these similar questions from Keith Williams GenNav. So watch those lectures. I have solved all such questions from those resources as well. Now the formula is rate of descent equals to glide angle, speed to 1013. You're converting knots into corresponding feet per minute divided by 60. Angle is 3 degree. Speed is 120 into 101.3 divided by 60. So 3 into 120 into 101.3 divided by 60 is 607.8 feet per minute. Okay. So the closest option here is option Bravo, 600 feet per minute. The outer marker of an ILS 3-degree glide slope is located 4.6 miles from the threshold. Assuming a glide slope of 50 feet above the threshold, height of aircraft passing the outer marker is what? So let's say this is your runway and this is the ground surface. On this ground surface there is a blue outer marker. That blue outer marker is located 4.6 miles from the runway. 3-degree glide path is there. Okay. Aircraft is here on this 3-degree glide slope. This 3-degree glide path is 50 feet above the runway. Okay, it passes 50 feet above the threshold of the runway. So we will make a triangle. This is 3 degree, okay, glide slope with respect to the with respect to this side of the triangle, because this glide slope doesn't end at the threshold. Okay, it ends somewhere further uh, further ahead of the threshold. So maybe at the touchdown zone or aiming point. So the 3 degree will be with respect to this imaginary line in the atmosphere. Okay, the distance is 4.6, that is fixed. Now we have to calculate this vertical distance of aircraft with respect to this glide slope, which is 50 feet above the threshold. So step 1 will be that. And step 2, to that height, we are going to add this extra 50 feet. Okay, because your glide slope is 50 feet above the ground surface threshold. They have asked us to find aircraft height from the outer marker. This outer marker will be on the ground surface. So we will have to calculate height of this aircraft from the ground surface. So first things first, let's apply tan theta formula. Tan 3 is opposite upon adjacent. So opposite side is x, adjacent side is 4.6 miles. So x will be equal to tan 3, 4.6 nautical miles. So tan 3 into 4.6 is 0.24 nautical miles, multiplied by 6,000, that is 1446, 1446 feet. So the height of aircraft, approximate height of aircraft over the outer marker is 1446 plus 50, which is equal to 1496, or approximately 1500 feet. So the closest option here is 1400, 1450, 1300, 1350. So option Charlie is the closest, 1450. Okay, next. What is the color sequence when passing from outer marker, then middle marker, after that inner marker? So outer marker is blue. So first you encounter blue color, then amber color, and then the white color. So blue, amber, white. Option alpha. Last question. What is the approximate angular coverage of a reliable navigation information for a 3 degree glide path out to a distance of 10 nautical miles? So, your glide slope signal will transmit two amplitude modulated signals, just like localizer does. 90 Hz signal will be above the 150 Hz blue signal. Remember this. Second thing, you have to remember this coverage. Now here is the uh, horizontal range shown to you. So horizontally on the ground surface, flat plane, your glide slope will be extended 10 nautical miles away from the runway, 8 degree either side of the center line of the runway. Vertically, your glide slope. Now this is your 3 degree glide slope. This is your 3 degree standard glide slope, theta, with respect to the ground surface. Now this glide slope will have a lower limit and an upper limit. Now this lower limit is 0.45 times theta. Okay, so 0.45 times theta means if the angle is 3 degree, so the lower limit of the standard glide slope will be 0.45 into 3. That means 1.35 degree. So that means this lower slope, okay, this lower limit of the glide slope will be 1.35 degree above the ground surface. And the upper limit is 1.75 times theta. So 1.75 times 3 is 5.25 degree. That means this upper limit will be 5.25 degree above the ground surface. Okay. So the correct answer here is angular coverage of a glide slope distance 3 angle 3 degree. 1.35 degree above the horizontal, 5.25 degree above the horizontal, 8 degree each side of the horizontal. So 1.35. It's 1.35, not 1.25. Yeah. So option A. So 1.35 above the horizontal up to a different value of 5.25 degree above the horizontal, 8 degree either side of the center line. So option A satisfies both these conditions. So option A will be the right answer. Now if they give you some different glide slope angle, 3.5 degree, 4 degree, 2.5 degree, whatever. So multiply that theta or substitute that particular value in place of this theta. So 0.45 multiplied by 4, 0.45 multiplied by 2.5, whatever. Right then, we'll stop here. I hope you have understood all the 10 questions that I have answered in this video lecture. If you have any questions, doubts, let me know in the comment box. I expect you learned something new today. In my next video lecture, I will solve the next 10 questions. So let's meet there.